The title of this presentation is Improved Prenatal Detection of Coarctation of the Aorta using Speckle Tracking Analysis of the Fetal Heart. I would like to thank my co-authors, Drs. Caitlin Haxel, Gary Setu, Mark Skolansky, Michelle Pelka, Pini John, and Bettina Cuneo from the Children's Hospital of Colorado and the Mattel Children's Hospital at UCLA. Coarctation of the aorta has the following prenatal characteristics. 1. It represents 5 to 8% of congenital heart defects. 2. It does not cause fetal circulatory compromise. 3. The aortic isthmus is not an essential component of fetal circulation. 4. The prenatal detection rates vary between 7 and 50%. And 5. The false positive rate is as high as 65%. Coarctation of the aorta has the following postnatal characteristics. 1. After birth and ductal closure, a critical coarctation results in poor perfusion of the lower body and acidemia that together, with an increase in left heart afterload, may result in acute circulatory shock. 2. Coarctation is the most common life-threatening cardiovascular malformation overlooked in the neonatal period. And 3. 60% of newborns with coarctation are diagnosed after discharge from the hospital. In 2011, the U.S. Department of Health and Human Services added critical congenital heart disease to the list of conditions recommended to states for universal newborn screening using pulse oximetry. In a study published in 2018, 77,148 newborns were screened. The authors reported 6 false negatives, of which 4 had coarctation of the aorta. No fetus with coarctation was identified in the screen positive group. This study, entitled Aortic Coarctation, a comprehensive analysis of shape, size, and contractility of the fetal heart, examined the 4-chamber view in the right and left ventricles, and identified changes in ventricular size and shape as well as ventricular contractility to be associated with coarctation of the aorta. Knowing the cardiovascular profile of the heart in fetuses with coarctation of the aorta, as just described, we propose the question, how can we predict which fetuses will have neonatal coarctation of the aorta from those who will not? Let's examine the measurements of the 4-chamber view that were used in the study. First, we measured the length and the width of the 4-chamber view in diastole. From this, the global sphericity index was computed by dividing the length by the width. A value less than the 5th centile was considered to be abnormal and associated with a globular-shaped heart. 2 measurements of the area and circumference were also computed from the 2 diameter measurements. Evaluation of right and left ventricles was done using speckle tracking analysis. Speckle tracking analysis evaluates movement of the endocardium during the cardiac cycle. What does speckle tracking mean? The endocardium of each ventricle is composed of digital pixels. The image on the left illustrates a portion of the endocardium of the left ventricular septum, which has pixels of various shades of gray in intensity, represented by the green box. These pixels, or speckles, located at different locations along the endocardial border, can be tracked by computer software as the ventricles contract. Let's now do a deep dive and examine what is being done by the software. From these thumbprints of pixels, 24 equidistant points on the lateral and septal walls are identified, represented by the red dots on the graphic on the right. For example, point 1 is at the base of the lateral wall, and point 24 is located at the apex of the lateral wall. Point 26 is opposite point 24 at the apex of the septal wall, and point 49 at the base of the septal wall is opposite point 1 of the lateral wall. Data from the locations of these points from each side of the chamber are used for computing the width of the segments distributed from the base to the apex of the ventricle, as well as the length. Using the right ventricle as an example, the user simply places the cursor at the base of the ventricle, points 1 and 2, and at the apex, point 3. This then activates the software analysis to compute the endocardial borders at in systole and in diastole. Once the yellow lines identify the contour of the endocardium, the user can adjust each point of the contour as needed. The graphic on the right illustrates the 24 segments, with segment 1 located at the base, segment 12 located in the midsection of the ventricle, and segment 24 located at the apex. In addition, the length of each chamber can be computed. These end-diastolic measurements form the basis for a number of derived measurements that were used in the study to compute the size and shape of the ventricular chambers. In summary, the following measurements were made. 1. The four-chamber size and shape. 2. The size and shape of the right and left ventricles. 3. Right and left ventricular global, transverse, and longitudinal contractility. And 4. Left ventricular function. Let's now examine the study fetuses. The study consisted of 108 fetuses who were suspected to have coarctation of the aorta following a fetal echocardiogram performed by pediatric cardiologists with specific training in fetal echocardiography. The analysis of the four-chamber view in the ventricles, as described in the previous slides, was done in a blinded fashion by Dr. DeVore. Following the analysis of the size and shape of the four-chamber view and the size, shape, and contractility of the right and left ventricles, the code was broken. The fetuses divided into two groups. 54 fetuses had postnatal coarctation of the aorta, requiring neonatal surgery, and 54 did not have coarctation of the aorta. The statistical analysis consists of the following steps. 1. The z-scores for all of the cardiac measurements were computed using the equation on the slide, in which the mean value for the control population was subtracted from the measured value for the study fetus. This value was then divided by the standard deviation for the control population, thus computing the z-score. 54 fetuses with neonatal coarctation were coded 0, and 54 fetuses without coarctation were coded as 1. Logistic regression analysis was then done, in which the statistical program added and removed variables to compute the logit value. The equation for the logit value consisted of a coefficient for each variable that was identified by the analysis. The logit value was computed by summing each of the z-score values multiplied by its respective coefficient. Once the logit value was computed, as described in the previous slide, the probability of coarctation of the aorta was computed using the above equation. If the probability was less than or equal to 50%, then the fetus was classified as not having coarctation of the aorta. If the probability was greater than 50%, the fetus was classified as having coarctation of the aorta. Let's now examine the results of the study. This lists the findings associated with coarctation of the aorta, which include abnormalities of the aorta, ventricles, atria, venous system, and aortic arch. This lists the findings associated with fetuses who did not have coarctation of the aorta, which includes abnormalities of the aorta, ventricles, atria, venous system, and aortic arch. This table summarizes the abnormalities between those with coarctation and those who did not have coarctation from the two previous slides. While the fetuses with coarctation had more findings involving the aorta, ventricle, atrium, and venous system, and the aortic arch, the non-coarctation fetuses had findings in each of these categories as well. This is the result of logistic regression, which identified 28 variables. Let's examine the variables that were identified by the analysis. The two variables from the analysis of the four-chamber view were the circumference and the transverse width. The analysis identified variables of ventricular size that included the left ventricular transverse diameters 4 and 8 and left ventricular volume and area. For the right ventricle, the basal apical length and transverse diameters 4, 8, and 20 were identified as well. The analysis identified the sphericity index, which measures the shape of the ventricles, for segments 8 and 20 of the left ventricle and segments 1, 12, and 20 for the right ventricle. The analysis identified the left ventricular fractional area change as a variable as well. The analysis identified measurements of the left and right ventricular strain that included the entire ventricle or longitudinal strain, as well as the free wall and septal strain. Measurements of ventricular basal apical contractility were also identified. Finally, measurements of left ventricular function that included the stroke volume, cardiac output, and ejection fraction were identified as contributing to the logistic regression analysis. The analysis correctly identified 96% of fetuses who had neonatal coarctation with a false positive rate of 4%. In addition, the analysis correctly identified 96% of fetuses who did not have coarctation of the aorta, a false negative rate of 4%. The area under the ROC curve was 0.98. What are the conclusions from the study? The question that may be asked is, why use this analysis? The answer is that it only involves the evaluation of the four-chamber view in the ventricles. The measurements derived from speckle tracking analysis may soon be available on ultrasound machines that are used in fetal medicine. In addition to other types of measurements of the aortic arch and isthmus, Evaluation of the 4-chamber view and right and left ventricles will complement other fetal findings. Finally, the entire analysis described in this presentation takes less than 5 minutes. Thank you for your thoughtful participation.